Alright, what's up chemistry? So I'm going to go through this calcium hydroxide titration with you to ensure that you understand it and can follow the steps involved. So part 1 said write the equation for the reaction between calcium hydroxide and hydrogen chloride or hydrochloric acid. So this is going to be your calcium oxide, CaOH2, plus HCl, and that forms calcium chloride plus H2O, and then balance that. You need to stick a 2 in front of this one, and you need to stick a 2 in front of the water. So what that tells us is that for every, if we just get a different color, every 2 moles of acid, 2 moles, there is 1 mole of calcium hydroxide. So the next bit says if we have 1 mole of HCl, how many moles of calcium hydroxide do we have? So we can do that by doing a ratio. So there's the calcium hydroxide, and that's going to be in the ratio to the HCl. We just saw from that that the HCl was 2, the calcium hydroxide was 1. So therefore, if the HCl is 1, the calcium hydroxide is going to be 0.5. So that's part 2. Part 3 says from the average volume of hydrogen chloride used, calculate the number of moles used in the titration. So I'm going to go ahead and assume I used a volume of 30 centimeter cubed. That may be a little high, but it'll do the job. Calculate the number of moles used then. Well, I know that N equals CV. I know the concentration of the hydrochloric acid was 0.05 molar times the volume of 30, and remember I have to divide that by 1,000. Let me just grab a calculator on my computer. Here we go. I guess that one will do. So 30 over 1,000. Yeah, it's a sweet mechanical hit. Keyboard you can hear there. Gives me 0.0015 moles of HCl. Okay, so that's the number of moles of HCl that I used. So we know here that there was 0.0015 moles of hydrochloric acid in our burette that we titrated down into the solution below. And that neutralized 10 centimeter cubed of calcium hydroxide. So the next question says, how many moles of calcium hydroxide would there be in 10 centimeter cubed? Well, if there were this many moles of HCl, and we know that the number of moles of calcium hydroxide is half the number of moles of HCl. So all I do is I take this number and I divide it by 2. So if I do that and I divide by 2, I should get the number of moles of calcium hydroxide to be 0.00075 moles of calcium hydroxide. I'm just going to double check that calculation because it's important that we get this right. My mental math skills are good, but this is the kind of thing it's easy to make a mistake on. Yeah, that's all good. So those are the number of moles of calcium hydroxide. Then next, if I just shift that to there, the next thing and the final thing for this part that it asks us to do, if I choose a, let's go with the black color, it says, okay, so that's in 10 centimeter cubed, so how many moles would there be in 1,000 centimeter cubed, which is 1 decimeter? So if I'm going from 10 centimeter cubed to 1,000 centimeter cubed, that's a factor of 100. So I need to multiply this by 100, which gives me, move the decimal point a little bit, is that 0.075? I think so. 75 moles. Again, I'm going to double check that calculation to make sure we get it absolutely right. Yeah, 0.075 moles. So what that's saying is, if we go to a new slide, there are 0.075 moles of calcium hydroxide in 1 decimeter cubed saturated solution. So we're almost there now, but if I'm actually going to find the solubility of calcium hydroxide, then I'm going to need to find the mass first. So part 5 is finding the mass. So let's just throw that over there. This is quite simple really. We know that the mass is N times mR. The number of moles is 0.075. The mR of calcium hydroxide is 40 for calcium, plus 32 for the 2 oxygens, plus 2 for the hydrogen, and that's going to give me a total of so what's that, 72, 74, so that gives me 5.55 grams. Okay, so that's the mass of that, and I can use that finally to work out the solubility, because solubility is the amount of mass that will dissolve completely in 1 decimeter cubed. So let's bring blue back, the best color in the world, of course. So we've got the solubility is basically the mass divided by the volume, and this is 5.55 divided by 1 decimeter cubed. So obviously 5.55 grams per decimeter cubed. This is about 3 times the book value, so it looks like our titration may have been incorrect. Looking back at the practical, I think maybe there was some calcium hydroxide that was undissolved in the solution, and we probably should have filtered that. That would have got rid of any excess calcium hydroxide and would have given us better results there. Finally then, question 7 for the percentage error. This is a pretty small error because it's a 0.1 plus or minus centimeter cubed error. So we're going to divide that by our actual value, which I took to be about 30, and times by 100, and that's going to give me a small percentage error, as you can see. So that's 0.1 over 30 times 100 is about a 0.33 recurring percent error. Okay, so not a lot of error. Our main error is not in fact the burette here, it's probably the fact that we didn't filter out any excess calcium carbonate from the solution. Anyway, hopefully you understand that now. I'd recommend you now, well, you watch this video again if you want, you really like the sound of my voice, but I'd recommend you now go away and work through those questions by yourself without consulting the video, and then check that you get a similar answer to what I just got. Hopefully that was helpful, and I'll see you all tomorrow.